Hi, my name is Ken Lasserson. I wrote and maintain the Microbiome Prescription website, dealing with how to improve your microbiome, your gut bacteria. And this is a overview of recipes. Recipes is how do you modify your microbiome to be better or better for you, for your medical conditions. And I have in preparation of some detailed ones, but I figure an overview may help a lot of people understand what's going on before they get lost in the forest with all the trees. So let's go in and take a look. Part of a series of YouTubes which I'm doing. First one was Who Am I? I'm basically a data scientist, ex-science teacher, statistician, etc. Master's levels there. Reading medical articles since I was about 14 or 15. The next section, which was free talks, basically was looking at trying to figure out what needed to be changed by using the names of the bacteria without paying much attention to what they did. The next one was a series of free looking at by the fruits of the bacteria, basically what chemicals they produce, what enzymes do they produce, and how do they fit into the KEGG Encyclopedia of Genes and Genetics data sets, which is a sweet set of data, complicated, massive, but sweet. And because from it we're able to look at your bacteria, find out what genes are in them, and thereby work from that to determine what is in or out of balance at the gene level. This talk is the overview of recipes, which is trying to do a quick synopsis of what we're trying to do and why, and things you should consider or try doing yourselves. And then we're moving on to the next series, which is building recipes to remediate the medical conditions that you have. In trying to address any medical conditions or symptoms, my traditional practice has been to take the best of all data sources. Don't rely on one or the other, but find everything and then combine it. And basically, the Venn diagram on the left shows you what the scenarios. We have clinical trials, which has tried a variety of supplements or other things on a clinical subset with or without success. And so it gives a list of substances. Then we have studies which looked at how certain substances modify the microbiome, increasing or decreasing certain bacteria. Clinical trials usually do not look at the microbiome shift. A few of them are starting to now, but the microbiome modifier is information that basically it's not looking at a medical condition. It's simply saying, oh, okay, if we give alpha lipoic acid to a person at this dosage, how does the microbiome respond to that? It may be a control group, it may be an unhealthy group, etc. So what we're trying to do is determine what's a probable outcome of a particular supplement or herb, diet choice, food, probiotic product on the microbiome. What does it shift? The third one is very much related, but we are stepping back and looking at the function. We're using the KEGG Encyclopedia of Genes and Genetics, their enzymes data, the modulars. And we are using that to try to identify where the particular unique mixture of bacteria you have are not producing enough or producing too much of a particular enzyme or other metabolites. Clinical trials, we are looking for ones which report positive results. When we look at those studies, we often find that a percentage respond. Percentage may be just 40%, in some cases 60, 70, 80%, but it's rare that we get more than 80% of the people being reported as positive response. To me, that's not surprising, because the positive response is often caused because whatever they were given alters the microbiome, and since everybody's microbiome is different, you are going to have some hit and some misses when you try giving any particular substance. That's why I ended up going down to the detailed microbiome analysis, because it would explain the difference in results and, more importantly, give a way to improve the results. Microbiome modifiers, things which may shift to the best of our knowledge. The amount of shift will actually depend on multiple factors. All it does is it gives us a compass bearing of what we could expect to happen, and other factors come in. It's like sailing a ship. Here's the compass bearing you want to set, but you have tides coming in, you have cross currents, and you have perhaps shoals along the compass bearing, any of which can cause problems. Similarly with the microbiome modifiers and with clinical trials. The KEGG enzyme monitor is far more on the theoretical ground. In some ways, it's more prospecting for things that may be worth trying, rather than blindly trying something. Oh, let's try this, let's try that. Oh, my friend so-and-so who has severe allergy got much better from that. So why don't you try this for Crohn's disease or Alzheimer's disease? It's sort of often what I call internet randomness, which I dislike because it means a lot of wasted money, a lot of wasted time, and a lot of patient frustration. It is very, very rare that any item will appear in all three of them. Occasionally they do. For example, vitamin B12 has shown up in all three of them in some of my analysis. So there is some overlap, but a lot of times you find something that changes the microbiome for a particular condition has never been studied for that condition in clinical trial. In other words, we have none of the gold standard benefits being assessed for it. We have a reasonable expectation, a logical inference. The other problem is sometimes these items will contradict each other. Not unexpected, because each is looking at it in a different way. The clinical trial may say such and such helps. But remember, such and such may have only 6% of the people, 40% it doesn't help. Something else based on your microbiome rather than a diagnosis may say, no, you shouldn't take this. The clinical study says you should. Guess what? You maybe have a microbiome that matches the 40% of non-responders in the clinical study. Interestingly, perhaps a bit more complicated, but it does illustrate what I believe is a reasonable model going forward. Now, clinical studies, let's just redo a recap. Rarely do all patients respond the same. There can be some dramatic shift for a few, contrary results for a small number, no results for a fair number. The results often may depend on the age of the people in the study, the gender, what the normal diet is, their disease or condition state, mild, severe, acute. Comorbid conditions they also have. Most of the time you will not get a clinical study with people with exactly one and only one condition to do it on. They look for somebody who has this condition and sort of exclude the most severe of other conditions, but you still get a hodgepodge of medical states of people in the clinical trial, which of course means that the data coming out of it is also a bit of a hodgepodge. And of course, the last key thing is DNA or SNPs. And in terms of microbiome, that actually becomes very critical, because we know now that the microbiome you have is inherited and it's tied to your DNA, which means that how you respond to a particular drug or a particular supplement may be partially influenced by your DNA that you have. And the microbiome that goes with it. Usually, clinical studies have the highest odds, not never guaranteed, just higher odds causing effect. Sometimes it may just be a 60% will get better, 30% will have no response, 10% will get worse. Not unusual, but it means your odds are that it will benefit. It just needs to be aware that things could get worse, and if possible from the original studies, find out how they could get worse. Microbiome modifiers means first you have to select a subset of specific bacteria which you deem are likely contributors. We don't know which ones they are. Sometimes people can be quite passionate saying it's just because this bacteria or that bacteria. Most of the time it's fuzzy. At best it's fuzzy. You have also that everybody's not the same. Your microbiome may not match the population used in a clinical study. So that's also a problem. It's what's called uncontrolled factors. The data for microbiome modifiers actually comes from 3 sources. The first grade of sources is human study, which may or may not be in the case of a specific medical conditions or diagnosis. So we have more uncertainty coming into it. Then we hit veterinary studies. Actually, vet studies have been actually very rich in getting information because vets are trying to have greater motivation and to try finding things, especially things such as changing of feeds or providing probiotics or adding minerals to farm animals and see what impact. Remember that a pig is very close to a human, so studies involving pigs showing that a particular shift happened has a high probability of being applicable to humans. So vets, I like. Vet studies are not to be sneezed at. You do have to read them carefully to make sure you are doing that they are reasonable to input. And the last one, which we find occasionally, is we find, for example, a simulated environment, often as a lab studies. The problem with the simulated environment is it generally does not capture all the complexities of the human environment, so that you have a prospect of going down the wrong path totally because of factors which are not being replicated precisely in the lab environment. But again, all this information is far from plentiful, and what we do is we gather up as much information as we can from each of these, and then we start working with that. As you see up above, a subset of specific bacteria is deemed to be contribution. So what we are going to do is we are going to target our recipe for that subset. Here's a catch. Suggestions can be very sensitive to the bacteria selected. Adding or dropping one bacteria to a subset may toggle something from suggested to avoid or from avoid to suggested. The catch is we are trying to shift many bacteria with many characteristics. Every food in many foods will impact many of the bacteria. When we make a choice of a modifier, we try to pick the ones that has the most desired impact on the most of the bacteria in a subset, and with the greatest amount of confidence. And confidence means how many studies shows that this substance will actually shift this particular family of bacteria or genus of bacteria in a desired direction. So we end up having to do a balancing act. It's not a absolutely, this is the magic substance that will adjust all bacteria exactly the way we want it. No, we have to do trade-offs. Changing one key bacteria can toggle things from suggest to avoid or from avoid to suggest. The subset which you're working from tends to be very critical for your suggestion, and making a minor change suddenly. But last time I ran it, it said take it. Now it says don't take it. You have to keep track of which bacteria are in your selection or how you're selecting them. Remember, our data is sparse and we don't have information on every item from human clinical studies. We are making the best effort which we can of what we do have information on, and the information is literally sparse. It's not greatly abundant. The KEGG gene base is an interesting aspect because generally we have the full genes of many bacteria. Since we know what the genes are, we also know what those genes produces. We can build distribution of what they produce from the samples, and then we can take a look at your samples compared to other people's samples, and be able to determine, do you have more or less of a bacteria? Are you at an extreme of this particular bacteria producing enzyme, or at the average? The nice thing is we're not doing it based on a specific bacteria. We're doing it by summing up all the bacteria that produces something, which means that when we come to adjust, we have more choices of which bacteria we may want to adjust, and with that we get the ability to do more sophisticated selecting of modifiers, because now we can go and say, okay, we got 5 bacteria which produce this substance and we want to increase it. Okay, if I take number 1 and put it in my subset, what did it come up with? If we pick number 2, what did it come up with? 3, 4, 5. One of those 5 bacteria may have a very similar type of modifiers to shift it, which the other things we're trying to shift have, which means we have convergence of what the modifiers should do. Other ones may suggest very different things which could hurt the other bacteria we're trying to adjust. It's a game, give and take, it's a balancing act. With the enzymes, it gives us more options for trying to figure out how to adjust the bacteria versus what we know modifiers do, because we can start picking from sets of bacteria rather than explicit bacteria. As you can see, we have a lot of linkages between, for example, enzymes and bacteria. We have over 5 million in our database, and in time I expect that to keep growing as more research gets published. So our goal now becomes to modify the microbiome to reduce surplus and increase deficits of enzymes and metabolites that we can determine. And the bacteria subsets are selected based on KEGG. Key thing is this allows substitution of bacteria by their function. The other methods, we were locked into thinking of a particular bacteria rather than what function they were doing. And it also allows us to deal with the case where you have rare bacteria which we don't know too much about, but we do know the genes, which means that we actually do know a lot more than what will be found on PubMed of what it does. And in some cases, the rare bacteria compensates for bacteria which are expected to be at a level and you are low at. So it sort of becomes running around the issue to realize, wait a minute, so there's a substitution happening here of one group of bacteria for another. I don't need to go and try shifting this bacteria over because I already have a mixture of bacteria that does what I want, or I need to just tweak one or more members of this collection of bacteria, and I can now look at which ones I want to tweak most. Okay, now let's go on. Key word: there's no magic bullet. There's no magic recipe. All of these are proposed recipes, and if you ever tried cookbooks, you know some recipes you get very lucky with and you have success. Other times it absolutely fails. I know for myself, and when I was doing a lot of cooking, Some cases, the choice of what milk you put in, was it skim milk, whole milk, 2%, goat milk, camel milk, actually has consequences. And sometimes the recipe only says milk without specifying what type of milk. So you end up trying different, and sometimes it works and sometimes it doesn't. So no magic bullet. All three gives you better odds than internet myths as to what you should do to do it. Some of the internet myths may be correct, but many of them I've seen I would describe as being closer to doctors at the QAnon medicine facility. They are hearsay based on A saying something, B which gets reported so often that it seems credible, but when you go over to try finding hard evidence of it, you either find no evidence or you find some slightly questionable evidence. For example, a particular probiotic was found effective in reducing histamine levels on fishes in markets. Okay, that does not mean that this particular probiotic consumes histamine. What it may mean is that it inhibits the growth of histamine producing bacteria, a very different case. So if you suddenly take it because, oh, it reduces histamine, it may not do it. While the study was based on was in a particular environment, very specific, and a lot of this type of analysis tends to be time consuming, which is why I usually try keeping to human clinical study as the first choice. Again, a lot of stuff on the internet in terms of medicines are myths, sometimes literally QAnon medicine, often promoted by somebody who has a retail product to sell, or who got sold on a product and had a positive result because of, for example, the placebo effect. Placebo effect reduces stress. Lower stress levels means microbiome shifts. So the product may not actually be causing it. The placebo effect may be causing it. Suggestions should be added in small groups, ideally add one at a time, and then determine does it make a difference. One of the key problems is how do you tell if it is a difference? You have to start thinking objectively, measurably. All three approaches tend to be blinkered. That is, it's focused on one particular aspect. I know people have in my collecting up data, one of the substances which I have in the database is Roundup, a pesticide. Generally, I don't recommend anybody to do the pesticide, but it is there because it does alter, exposure to it does alter the microbiome. It can be helpful for somebody who has been exposed and who have microbiome things to look up what the shifts are. And I basically have had a practice of hands-off trying to be filtering and select. That's for your medical professional to do. So side effects may exist. Suggestions should always be viewed by a knowledgeable medical professional. I have no idea where you find one, but that's what they should. Okay, let's do a quick summary. And the summary is by describing common mistakes. Number one error I see constantly is people being in a hurry. They try a lot of changes at once, and that is bad. And why is it bad? Because you may try 8 items, 5 of them actually help you slowly, 2 does nothing, and 1 has an adverse reaction. Which one of the 8 causes adverse reaction? Or do you just blow all of them away as being useless? You are setting yourselves up to going back and forth like a yo-yo or ping pong ball, going back and forth and not making progress. If you want to make progress, you need to be systematic and doing small baby steps. No sprints, please. Number 2 is forgetfulness with no records. And this, especially for some conditions like chronic fatigue or anything that has mental fog or cognitive issues, is critical. Items may help over a 6-week period, but most people's memory is only accurate to a few days at best, sometimes not even a prior day. You need to keep a journal. And you need to try doing objective measures, as many as possible, because you may be focused on one thing, but it may cause other changes. If you see other changes, you know something is happening. It may not be the particular change you are blinkered on, but a change is generally a good thing. Some examples are number of bowel movements per day. Perhaps put a sheet in the bathroom and set up a lumberman's tally, which is a tick, tick, tick for every bowel movement, lying across for each day. For the next day, do a tick, tick, tick. So you keep track of how many bowel movements you have each day. Putting it right by the bathroom has the advantage, as you're sitting right there in your face, you're not having to remember to go and open up a tablet or PC to make a record of it. Stool types. Don't be afraid to take pictures. That's why God gave us smartphones with cameras, so we can take pictures of our stools. Please remember that. The pictures of stools saves you from having to try to remember which one of the Bristol stool types you have. You have the picture or record in front of you, and you can look back. Makes it easy. Just don't share the pictures, please. Other people may not appreciate the importance of stool pictures. Things like saturated O2, blood pressure, temperature. For example, I use a smartwatch, cheap smartwatch, $20, and it periodically, as in every hour, measures my saturated O2, blood pressure, temperature. These are not medical grade measurements, but they are sufficiently accurate that you can use them for detecting trends, and that is sufficient for all needs. What's your physical activity? How far do you walk? If you are dealing with something like chronic fatigue syndrome, you should go and try making a walk every day. The exercise has definite microbiome shift aspects to it, and just track how far you do it, or after smartwatch, count how many steps you are doing each day. Again, you want to do it so that it's something that happens every day in a repeatable manner. Mental activities, certain types of games, certain types of online memory games. Do that, record the results. Again, journal, because if you don't, you may come to the erroneous conclusion it's not helping and stopping something that is helping. Again, this is a very common error I've seen personally with people around me. I've seen that happen, and you do need to get the discipline or leave big reminder notes on everything to journal. Last issue is people wanting certainty. I want to know exactly what will help. We don't. What we can do is give suggestions which have better odds than random suggestions or cruel medicine suggestions. So with that, I want to do a quick hop over to taking a look at a couple of things which could also help you. First item is sort of clinical studies. Many of you know I have a blog with something like 1,400 separate blogs. Almost all of them are research in terms of linking to PubMed articles, which I use as a basis for it. I, in essence, work as a librarian to assemble it. The thing many people don't realize, or who are not well internet savvy, is the ability to search on a specific site. It just can be any site you want. It could be somebody else's blog, but site, the name of the site, and then what you're looking for. For example, I put in word zinc. Apart from the paid advertising that shows up there, you will see a couple of links towards where the word zinc shows up on my blog, and then down below additional ones. So for any of them, what do we do? Let's see what we knew in 2017. If we click there, we go over, and as you can see, Most of my pages are not verbal commentary. It is trying to find the best quote from a specific study and literally quote verbatim, word for word, so that my own personal spin or bias is minimalized. Followed by a link to the study. For example, here, dryness of eye symptoms associated with low zinc level. If you click there, and we find, and the study actually doesn't explicitly talk about zinc, but if you go and read into the article, you will find that they noticed in passing that low zinc level was associated with dry eye and other things associated with dry eye. If you go back and go all the way back, and if we type in the word dry eye, we have more information about dry eye, and again, things like probiotics for mouth, sinus, and eyes. If you're interested in that, you click through and you find out again what's from PubMed. You can read all the stuff. Now, since we're on PubMed, you could actually just go to PubMed if you want and type in, let's say, dry eye, and you're interested in probiotics for dry eye. Simple as that. And we find there are 11 results. And now you proceed to have the fun of trying to read through and extract information. One which has free PMC articles are often the best. The rest of them tend to be short summaries. And if we go and click that, this is a new study. And we have here over here, and we can go down and we can proceed to read through it. Gives you background, gives you information, lots of technical information, and we okay, so we have medical conditions, ocular diseases. So here we have eye issues and which bacteria are increased and decreased. Also, if it's a human study or not a human study. And all of the stuff is linked over to the PubMed study. So you can go through there. But as you can see, you have to do some wading through some technical literature. Sometimes you can find nice, easy charts, which makes life easier to work with. So that is basically it. Now, so that covers the aspect of clinical studies and how to find it. You can again do the search mechanism on anybody's blog or whatever. Always try finding the original source document. Often there can be misinterpretations happening in bloggers, especially if they are incentivized by product promotion. Okay, now let's go on. And the second part was dealing with modifiers, things that alter the gut bacteria. And what I have online is I have available my database. So if you are looking for a microbiome modifier, you go here and you can type in, for example, let's say barley, which is one of my favorites because it has a lot of stuff. So you could also do something like, for example, if you want to look at a vitamin in general, you'll get a long list and it does a broad search. Some cases, if that vitamin is mixed with other drugs, you may get a combination, or it is in the combination with some other drugs, then it can happen as happens down here. But most of the time you should find it's very easy. Let's take a look at something like folate. And now you can see what it modifies. And we have 565 items. Cough, cough, cough. and that's supposed to be looking at bifidobacterium. In the search box here, you can just start typing and it will filter it, and we can see it will increase, decrease. You'll notice we have a variety of icons here, and the icons means that this information doesn't come from a study that mentions this specific thing, but comes from a study where its parent is mentioned, which implies that it is probably likely to also be mentioned. So if I click here, and we have here a list of articles, and then clicking through, we find out that the study which you look at the deficiency. So if you're short of things, this is a shift, and from that we build our database indicating what is reduced with it and what should in theory be increased with it to some extent. Again, we have the full information there. So we have a little bit of sweetness there. And for medical conditions, we do have similar ability. For example, let's look at dry children thing. So we have here a summary of the bacteria. These won't necessarily always be complete. Some cases like what we just looking at, it was looking at eye diseases and microbiome shifts. This is a specific eye condition, so it would be a subset. But again, we see what the nature of it is, and if you just click here, you go over and you can see where the article it is, and you can go and click and go to the publication and read more up on it. So that gives you a general overview as well as a walkthrough of some internet skills to help you find information so you can better figure out what you need to discuss with your doctor in terms of improving your symptoms or your medical conditions. Okay, that's it. This was again a quick overview to show you what I'll be talking about in detail, i.e. a long hour and a half sessions coming up.